So here we have induction proof. So we're trying to prove for every natural number n that 1 minus 1 over 2 to the n equals the summation of 1 over 2 to the k as k goes from 1 to n. Boom. Now we do the base case. Yeah, we chose n as n equals 1. Then you have 1 minus 1 over 2 to the 1 equals 1 over 2 to the 1, which is half, equals half. That's correct. So therefore, this holds for this case. And yeah, induction step. Let k be a natural number, elements of a natural number. Now, this was already proven by the base case, okay? This whole thing. What we're trying to prove now is by adding 1 to the 2k plus 1. So this is already proven by the base case. You just add 2 to the k plus 1 equals, to the left-hand side, you also add 1 over 2 to the k plus 1, right? Now, we already know that this works. We're just trying to manipulate this so that it holds to be this. This is what we want at the end. That 1 minus 1 to the 2k plus 1, which is the next following term. So now we come here. This right here, what we're doing, we're just trying to find combined like terms, right? When we simplify it, we get this. We simplify one more time after combining all like terms. You get 1 minus 1 to the 2k plus 1, which is what we wanted. By PMI, that statement holds.
All right, we'll be doing a proof by contradiction. It's an alternate way of being able to prove a statement, whether it's true or false. The goal is that for any statement, we assume the opposite to be true, and we find that there's some sort of contradiction within it. And so we know that because a statement can either be true or false, if the false brings up some sort of absurdity, we know that the opposite must be true, or that the statement is actually true. So for a conditional statement, prove that if n is an integer and n cubed plus 5 is odd, then n is even. The opposite of that is assuming the first part before the comma and the negation of the second statement. So if n is an integer and n cubed plus 5 is odd, then n is actually odd. So we first assume that. So n is some 2k plus 1, where k is an integer, and that makes n odd. And so this is our algebraic expression here, and we'll be showing that there's a contradiction from our assumptions. So once we compute everything out here, we show that everything is divisible by 2, and we group that all out, and that shows that it's a contradiction. We assumed that n cubed plus 5 is odd, but we've shown that if we assume the opposite to be true, that it actually contradicts our assumption. And we show that it is in fact even. And all of this, it doesn't matter what this is. The fact that it's multiplied by 2 will mean that it will be even. That contradicts our assumptions there, and that proves that the original statement, back to the opposite or back to the original statement, must be true.
This case holds. Thank you for watching.